Hello and welcome. My name is Kevin Adair and I'm part of the Yokogawa Australia team. I'll be your host today in this video. Today I want to talk a little bit about the Sebol control language inside Centum VP. It is a very powerful tool for doing many of the automated tasks within Centum VP. And while we do have logic charts and sequence tables available to us, probably one of the more powerful tools is the Sebol control language. So what I'm going to do today is I'm going to experiment with only one aspect of the Sebol language, and that is with the drive command. In order to set this up, I'm going to go into System View, and I'm going to open up a control drawing. Right, the first thing I want to do is go ahead and get myself a sequential function chart, and there are three types. I'm just going to take the standard switch type. Place that in the canvas and let's give it a name, sequential function chart 0, 0, 9. Right. Because I'm going to be using the drive command, I'm also going to go ahead and I'm going to put in two switch instruments to drive two control valves. So I'm going to place these in advance. Valve 03 and valve 04. Right. In order to program the sequential function chart block, I merely go to the Edit Details dialog. Inside the Edit Details dialog, I can go ahead, put a comment on it. Maybe I'm going to call this valve control. I'm going to go ahead and go into the sequential function chart component here. Each sequential function chart requires at least one step. So I'm going to go ahead and place that inside here. I'm going to go and select properties, and I'm just going to give this a command start. In order to get to the actual Sebol code component, I select the step action editor. Once I'm inside the Sebol editor, I can now go ahead and define my controls. The Sebol language has a predefined set of controls and syntax, and what I would suggest you do if you wish to know more about Sebol and programming is to come on one of our courses. The Centum VP Advanced Training course covers these aspects in detail. The first thing I want to do is go ahead and use the define command, because I want to change the command for open and for closed. The next thing I want to do is I need to tell Sebol that I want to make use of the two switch instrument blocks. And valve 4. Right. Now I'm going to use the drive command. It's just straightforward drive. I open the square brackets and I instruct Sebol to take the first control valve and the second control valve, and because I've used the define command I can merely stipulate open for both of these valves. Now usually when we are defining commands like this within our code, we also want to trap errors. It's good engineering practice, so I'm going to go ahead and trap my error in a subroutine, which I'm going to call error 001. I'll just make that 2 for now. and I'm then going to instruct the code to end. Now, because I've defined the error subroutine at the top there, I'm going to go ahead at the bottom here and actually tell the Sebol code what I wanted to do if it finds an error or encounters an error. So I'm going to type in here, go ahead, send me a message, tell me that the valve open failed, and then stipulate which line that error occurred in, convert the number, the error number, it's case sensitive, error number for me so that it appears in the error message, and then go ahead and give me the error code as well. That'll tell me what the code number is, and again interpret the value for me and give me the number. At the end of that period, I'm going to go ahead, I should actually just close that little comma, and down the bottom here I'm going to go error return, and I'm done. Right, now that I've got the code in, basically what will happen is when I run the sequential function chart, it's going to drive that valve 3 and 4 to the open position. If there are any errors, it'll go ahead and trap those for me and write them into the alarm history database. Right, go ahead and close that. Go ahead and update my functions and save. Now, provided there's no errors, the command will go ahead and execute without error. I see I've got 2 errors here, so I'm going to just go back in there. Looks like a spelling error on my part. Too quick with the typing. And that's correct. I'm missing a 0 here in my error sub. Right, let's try that again. I've got another error sub error there. Got to get that syntax right. Right, I didn't tell it what error code to return, so error L. And give me error C. These are just error codes which the system can return to me, and they provide the error details. There we go. There's a whole host of them, and you can find more information about each of those in the StoryView online help. Right, that should hopefully set us right, which it does, and now we download that to the controller. Obviously, before you do any downloads to the controller, make sure that it's safe to do so. I'm running in a test environment here, so I'm a little less concerned about impacting the process than you would be if you were actually on the plant. Right, what I want to do now is I want to call those items up in my operator station, sequential function chart number 9. I want to call up valves 03, valve 04, right, these two are both in manual mode. Now what I'm going to do here for this particular exercise is I'm going to place these 2 control valves into a simulated mode. I'm doing that because I don't have a motor control center or proximity switches feedback on these items. These particular tags, I've set SIM to 1, that just bypasses the answer back alarm, so I don't get any issues there. So I should be able to now move both these valves into an on-off position manually. Just testing them to prove that they will switch between the off and on state. Very good. Now obviously I can change the text on the buttons, but I'm just going to leave the defaults in place for this exercise. Now the sequential function chart, if you go to the tuning parameters, you'll see that there is a little icon at the top here which allows you to view the code. So I'm going to go ahead and view the code, and if I double click on my step, I can then actually watch the execution of the individual code as I'm going through it. Right. So currently I've got both the valves in manual mode. I'm going to switch them to automatic mode. And I'm now ready to go ahead and test my code. In this case, I'm going to just switch the sequential function chart to the run state. And I can see down the bottom here I've moved to drive. The two valves are moving to the on position, which they have, and I've then completed the execution, and the sequential function chart returns to its normal stop state. So from this example, you can see how quick and easy it is to actually put Sebol code together and to take automatic action for you. Now what I'm going to do here is I'm going to go ahead on valve number 3, and I'm going to put this back to manual mode. I'm going to go ahead and do the same with valve 4, but I'm going to put valve 4 back into automatic once it reaches its closed state here. And the reason I'm doing this is because I want to show you how we trap the error. Now, it's not going to be possible for the drive command to drive the valve 3 to the open condition. And the reason for that is because it's in manual mode. And you can see in my code I've not provided any trapping for the wrong mode. So obviously if an operator was trying to put this into an open state and it's not in automatic mode, it would not allow him to do that. Right, so what I'm going to do now is I'm going to go ahead and start the sequential function chart again, and you will notice that the valve 4 does go to the on position, but the valve 3 failed to get there. That should have trapped the error in my error sub. And so what I'm going to do now is I'm going to go into the history log, and I'm going to go and see whether that error was actually trapped. I'm in the CAM's history log right now. I'm going to just set for events. I'm going to switch off the other filters. Okay, and here we go. There's my sequential function chart 9 going to the run state. It's trying to open valve number 4, and it has failed, and it's telling me it's failed on line 6 with error code 121. And if I have a look here, line 6 correlates to the drive command, which is correct, and the error code 121 will tell me what that problem is. Now I've not trapped it any further than that, the message, so I would have to go into story view, and I've got my error class codes up here. I'll scroll down until I find error code 121, and there it is. It tells me that the block mode in which the setting is prohibited for the drive statement. In other words, I'm not in the right mode. Now what I could do at this point, if I want to correct that process, is go back into the engineering mode, go to the control drawing, and I could place an if statement there. That's as if the valves are not in automatic. Then go ahead, place them in automatic, and then execute the command. Well, this is a very short tutorial. I just wanted to show you the power and the flexibility of using the Sebol code. If you wish to learn more about Sebol and the advanced features of Centum VP, feel free to register with us to do the Centum VP Advanced Training course in any one of our centres around Australia. Thank you. Until we meet again, go well.